Hey, basically I would like to build a light switch switcher, and I've done this before several times, different implementations and different light fixtures and things. But this time I felt like I'd probably just go a little bit too much or all in or whatever you want to call it, and like use a large stepper motor and hook it up on the good old Wi-Fi, and build and program and design the whole thing. Uh, so in the past, I've used servo motors, like small ones, the G9s. If you're familiar with them, they're real easy. They're used by hobby flight people as well. And basically, you can just hot glue them to panels and change out your light switch for one of those like rocker switches, like up there, this and then that like switch, and you like push here or here, right? And you can simply just put a servo here, and its arm will reach out and touch it, and over here. So you have two servos, and its arm will reach out and touch it like that, just bam. So you can just be like, programmatically be like, on, I want this one to fire, off, I want this one to fire. So that's a real workable design because, these things are mostly out of the way, and you can still just push it with your finger, right? But I'm kind of just going all out here. And well, we're gonna going all out here. Don't save. And I want to make something kind of like it will be basically a fixture over the light switch itself. A little bit. There's my light switch. You can see that I obviously took some art classes. There's the switch. Anyways, I have like a stepper motor here that has like a real like belt drive here. Something sticking off of it, something sticking off at the bottom as well. I think probably another belt drive here. This is going to be driven by the motor on this side, and this will hook up, so it'll be able to like corral this thing, if you will. And then I think necessarily I'm going to need to have like little touch sensors here at the top and bottom of where I expect this little thing that's going to corral it to stop at. That's kind of purpose defeating for honestly kind of purpose defeating for a stepper motor, because the stepper motor, if you're unfamiliar with it, let's go back over here as you can see something more interesting. Stepper motors, they don't all look like this, but a lot of them do. They step like incrementally, one at a time, or a number of ways you can do it, but basically they're high fidelity motors that allow you to track where you want to put the motor. So you can tell it where to go to, but you don't know where it starts at necessarily, so you usually will have like sensors to let you know that. One of the upshots of this, they're usually pretty high torque motors, because they have to guarantee air quotes, that when the belt turns that you're going to get X amount of movement. So in this case, it's just like overly powerful for a light switch, which is good because the little servo things I showed you that setup just barely works, right? It's the servo motors are, those cheap servo motors are not strong, so results may vary. Anyways, so I want to get this thing to flip over, but what I would like to do is get it on the Wi-Fi as well. So I'm going to use an Arduino to drive the motor here, and I'm going to use a Wi-Fi chip. I'll put like stuff in the description if I don't get around to it. So a Wi-Fi chip is like ESP668 breakout of something, but I'll put it down there to receive the data. You can actually do programming on this chipset. It's really cool. I've got like a small web server that I've tested a few times on this. It's not that hard to load to it, but I probably can drive the stepper motor directly from here. But as mentioned, I want to have like touch sensors on here, and then probably some extra stuff that after I get this first level of this thing working. So I was like, you know what? I wanted to use it in tandem, the chip with the Arduino. So I'm just gonna do it this project for fun. I'm already doing an overpowered motor for fun, so we're just going down that vein, if you will. So if like general breakout, I guess, if you're, I don't know who's watching this and what the backgrounds are, but what I would like for this to happen is to just have some Wi-Fi message come over to the chip here, and then sending a signal on or off. I'd like to use the I2C protocol because I've used it before for other things, but always just messing around, never in a real project. Might be overkill for this, probably is, but it has to go through a logic level converter because this is 3.3 volts and this is 5 volts, and we need these things to be able to communicate back and forth over the I2C here. Go to the Arduino, and then it has a stepper motor it can control, and on startup it'll move, like, let's say up until, you know, sensor 1. Oh shit, I got like stepper motor. That's wrong. Now, let's see, 2. Bam. If you're not familiar with Draw.io, there are a lot of tools like it. I like this one. It's real easy to use and free, which is awesome. And integrates into a lot of really cool platforms, so you can use it in more than one place. But anyways, so like go up until it hits button sensor, and then at that point I'll already programmed how many steps it is back down to sensor 2, right? I can use it as confirm as I want. Again, once you start just using the buttons, you really kind of purpose defeating for the stepper motor, but it's still cool, and it'll be instructive for my later builds using the stepper motors and stuff. So, you know, one thing at a time. But anyways, it's a basic flow from here to there. The powering of the system is a little bit odd. So I've got 2 different microcontrollers on here and a stepper motor. Obviously the stepper motor is going to be running at a higher voltage. I can run it off the 5 volt. I think I've done that before, but it was pretty anemic if I remember, and, you know, screw it. I was like, let's go for a 12 volt power supply on that. And so we have a separate power supply for I've got 2 of them. That's pretty awesome. So this is having a moment apparently. But anyways, stepper motor here, powered by the 12 volt supply, and then after that I have a USB power, USB 2 power to the Arduino. And then after a little bit of playing with it, I could have another USB adapter running to it, but I'm already having 2 different power cables running up to the Arduino. Or to the light switch itself at that point, so I didn't really want to have a 3rd one in there. I could do some work. I got some voltage regulators which will take this down to 5 volts, but I'm not getting into that at the moment. I'm just going to keep it with a USB 2 power supply to the Arduino, and then I'm going to connect the VIN on the Wi-Fi chip to the VIN on the Arduino, because if I recall correctly, it just flows. Those 2 things are just connected, like the VIN on the Arduino and the 5 volt power supply from the USB 2, or 5 volt from the USB. It's just connected, just nothing in between it. So I'm basically just rerouting this like a socket into the VIN here, which is VIN to VIN. You don't usually see that. I just was trying to cut some corners there. And of course all the grounds are connected, which should be fine for the 12 volt supply here. Full like disclosure, I don't have any background in electrical engineering. I haven't even taken physics. I am a programmer. I have a bachelor's degree in that, but like didn't take any. I took a degree path that was focused just on programming, so IT with a specialization in software dev. So I didn't take physics. And I've had to just basically learn, Google and experiment until I've got a reasonable understanding of the basic concepts, or less than basic concepts. Definitely wouldn't say I have advanced knowledge of electricity, because my understanding is experimental. But anyways, so that's the whole idea, what this is going to look like. And this is what I have set up right now. Basically, I was going to update this after I do some more work on it, because something will go wrong and I'll have to change something. That's just the nature of this project, at least for me. I'm sure if you're an expert, or, you know, have an in-depth knowledge of electricity, you probably have less missteps. But I'll just show you what's going on with the board right here. You can't really see through all the wires. I apologize. I'll probably get a different camera set up at some point, just for my own good at least, if not for recording and stuff. The camera I have here is actually like a microscope camera. I've got backed off far away, which is good for like in-depth shots, because it doesn't need it to be a high quality camera. But for like the macro shot here, it's a little bit fuzzy. Anyways, basically the Arduino over here, I've got 4 outputs, and they're going over to, I think, LD 69. I'll put it in the description. It's just a stepper motor driver. So 4 outputs. Power goes in from here. That's the 12-volt power supply, and it's rigged up on the chip. And also, there's the 5-volt power supply from the Arduino is hooked through the chip here. And basically, one signal opens up a gate and lets power from here go through, go to like one of these connectors here. I think it's in there. It's the third, I think. Anyways, it lets this power flow to one of the inputs here, and it just turns on a coil and it turns over. So this is all handled by the Arduino through the motor library. I'll have to go back and look at it. But it's one of the stock libraries, not a big deal. Right now what I'm working on is this piece right here. So basically I'm going to try to take the signal in from the Wi-Fi receiver and just pass it to the Arduino after doing a little bit of processing with it. So I'm hoping that I can just put it on, use the I2C protocol and put it in the correct slots and do that. But the only example I've seen of that so far is someone who disabled the Wi-Fi chip and then did that. So these could all be running on the same port, and probably are. So I'll figure that out when I get there if it doesn't work. But basically I've got inputs here, and this is the voltage, the digital voltage. It's not a rectifier, but the words for this. Basically, it just allows you to go from one voltage level, one logical voltage level, to another one. In this case, it's going from 3 volts to 5 volts and back and forth. So that's what that does. I need to hook this up to the Arduino. At this point, I'm going to just cut the recording and go to work, and then update this once I have something to show. So thanks, and bye.